everyone. I wanted to go through Lab 2 to make it easier to do for you. This is our Topographic Maps lab where we will identify basic components of topographic maps and demonstrate knowledge of these maps by creating our own and an elevation profile from a topographic map. So this front matter, as we call it, everything before we start the lab, has a lot of useful information that you need to answer the questions. A topographic map uses continuous elevation lines that we call contour lines to show the shape of the Earth's surface. And these contour lines are imaginary lines that represent areas of equal elevation or distance above sea level across the Earth's surface. We have 10 rules here for contour lines. I want you to go through those to better understand this. We're going to be looking at the USGS Patrick's Basin topographic map. It's a quadrangle. It's an area that I've worked in the Rocky Mountain Front and Sawtooth Range of Montana, and it is complex. There's a lot of up and down. It does not look like the Saginaw Bay area whatsoever, aside from a body of water, sure. And so I want you to go through this information before you answer these questions. If you have any questions about the questions, you can always email me, but this isn't meant to be the hard part. Getting to the more difficult part. I took points of elevation from an area in Michigan and left only points, and I want us to all draw contour lines around them or through them to create a topographic map. Now, due to printing constraints, this isn't oriented properly, so I'm going to show you this in PowerPoint and trace the first few lines to get you started. So what I want you to do is look for the highest point of elevation. That's 1,460 feet. These tick marks are feet. Okay, that's the units that we're working in, a relatively low elevation area. And I recommended a contour interval of 40 feet. So this is 1460. How about our first contour line equals 1,440 feet, or 1440 feet. Oh boy, that's weird. It made it just an oval. I don't like that. But that's okay. All right. And then our next line is 40 feet down. We're going to put that through 1400. No oval there. Awesome. Okay, and then we have to go down again because we're going down in elevation. We see these points are lower in value than 1460. Okay, so 1400 minus 40, that would be 1360. That would be what this contour line represents, 1360. It gets pretty tight in here. Oh, wow, another oval. So then 1320 would be next. All right. And then 1280. Okay, so it's pretty steep up here towards the highest point of this small mountain. Okay. So when you go through and you draw your contour lines, they're going to be very close together. When you have contour lines be close together, that implies that something is steep. We'll leave that part. If you have any questions, you can always email me or come to office hours. We can talk about it. This one is our elevation profile. I'll zoom out a little bit so we can see better. The first thing I want you to do is go to this link and look at the tutorial. I'm giving you my own tutorial here, but this gives you more examples of what it looks like to create a profile from a topographic map. Okay, so what I did is I took our quadrangle and I drew basically a profile or a line through it. So that's A to A prime. And we're interested in all the points where the contour line crosses this line. Okay, because we're essentially slicing through this. And we want to know the value assigned to each of the contour line because we're going to plot it below. If you want, you can print this out and fold your profile up to the A to A prime line and draw tick marks to show the spacing wherever a contour line crosses, and then you can draw your points of elevation down here below. Or you can do what I did, which is I just use draw tools in Word to draw lines down to start my profile. So the lowest point I put on here isn't one that we have. It's 4720. We don't have a line that's representing that specifically. But first off, I figured out what these lines are based on the index lines shown. So you can see these bold lines that cross A to A prime. Well, they're 200 feet apart. Okay, so this one is 5,400. Okay, and then this one is 5,000. And this is 200 feet apart as well, because I know my contour interval is 40 feet for this quadrangle. And I listed it above. So this is 4,800. And we're going down in elevation over here. You got to pay attention to those things. And you can also identify this on the larger quadrangle to look at it in a different way. We have a peak elevation right here of 5,296. Kind of like what I showed you in the previous exercise where all you have are points of elevation. Here we have a lone point of elevation as well as an index line. So, okay. So what I did is I drew dash lines down just to guide where I plotted these things. And I gave you the scale itself. And each line that we have here is separated by 80 feet. Okay, so we're going to be plotting a point. Basically, they're each going to be 40 feet apart because the contour interval is 40 feet. So my first point that I plotted, that was 4760 right here. And then my next one was 4,800. That happens to be a bold index line as well, so it's easy to see. Then 4,840, then 4,880, then 4,920, then 4,960, and then 5,000. That is another index line, so it's easy to see. It's bold and it's labeled. We continue to go up in elevation here until the next index line of 5,200, and then we have other lines in between. These are kind of the peaks of the mountain, and then we're going to go back down in elevation. So it takes a little bit of time. You got to look at it, you got to think about it, but it's completely doable based on the information provided. And if you have any questions about this lab, of course, do not hesitate to email me.